There are several pieces of irrefutable evidence supporting the wave nature of matter, particularly for microscopic particles like electrons. Here are some key examples. 1. Electron diffraction experiments. The most celebrated and definitive experiment is the Davisson-Germer experiment, 1927. They aimed electrons at a crystal lattice and observed a distinct diffraction pattern, similar to X-rays passing through slits. This directly mirrored the behavior of waves interacting with obstacles, proving matter could exhibit wave-like properties. 2. Double-Slit Experiment with Electrons. Inspired by Young's double-slit experiment with light, similar setups were conducted with electrons. The resulting interference patterns observed confirmed the wave nature of electrons, showcasing the same constructive and destructive interference patterns as with light waves. 3. Neutron interferometry. This technique utilizes highly precise setups to split and recombine neutron beams, demonstrating interference patterns characteristic of waves. It further solidified the wave-like behavior of subatomic particles beyond electrons. 4. Electron microscopes. The high resolution achieved in electron microscopes, far surpassing optical microscopes, relies on the wave nature of electrons. By using electrons with shorter wavelengths, we can probe structures much smaller than the wavelength of visible light. 5. De Broglie hypothesis and wavelength. French physicist Louis de Broglie in 1924 proposed that all matter in motion exhibits wave-like properties. He postulated an equation relating the particle's momentum to its wavelength, lambda equals h/p, which was later experimentally verified through diffraction experiments.
However, based on my studies, the wave-like behavior of matter tells nothing unusual. In fact, space is filled with a super thin form of matter. This matter is produced by mass defects. In fact, every mass defect in the universe creates or produces this kind of super thin form of matter. Mass defect. Where there is a mass defect, the missing mass is exploded violently and becomes this super thin form of matter. In fact, the entire universe is filled with this type of matter. Therefore, a particle such as an electron cannot travel in a straight line when it is accelerated. When a particle moves through space, it constantly collides with these space-filling particles, and this results the electrons or any other particle, moving particle, behave like a wave. When you pass a beam of particles through a double slit, since this travels as a waves, they can interfere each other. So, according to my studies, the wave-like behavior of matter tells nothing unusual. I am Joseph George. You can watch my other videos also. Thank you for watching.